Solve. Express your solution in a graph and in interval notation. So the answer we come up with for this one, we're going to express in terms of a graph and interval notation like I did the last video. I gave both parts. So for this one, I'm going to add 6. And what's going on with this is I treat this just like an equation for the most part, with one exception. And we won't see it in this problem, but the next one we will. Okay, so this is going to give me 2x, and this is going to be greater than or equal to 9. And then what do? I divide by 2. Now that makes sense because think about this here. This side is bigger than this side, bigger than or equal to. So that means if I add the same amount, this side is still going to be bigger. If I subtract the same amount from both sides, this side will still be bigger. So it doesn't change anything. That's why it works like an equation for the most part. So now when I divide by 2, I get x is greater than or equal to 9/2. Now to draw the graph for this, and I'm just going to put G for graph, and I'm going to put the 9/2 on it. And now I just got to figure out my direction here. So now x is greater than or equal to 9/2. So that means I'm going to be on the right side here because x is larger. And I'm using the equal here. So that means I'm going to use a bracket. And then there's no upper bound for this thing, so it can go on forever and ever and ever. So it's going to be just like this. Now notation, I should say interval notation. Should call this IN. Yeah, that's good. IN for interval notation. Okay, now that's going to be very similar. So bracket negative 9/2, comma, and since I continue to the right, it's going to be infinity. And again, remember, I have to use a bracket because infinity's an idea. I never really attain it. Okay, now let's take a look at the next one. Now for the next one here, we're going to have to distribute, do all that equation stuff that we did previously. So this is going to be negative 12x, and all I'm doing is distributing here, plus 24, and then it's like I'm going to slide a 1 here and distribute that through now. So that's going to be negative 2x minus 4, and that's going to be less than 12. And all I'm going to do here on the left side is combine what I can combine. That means just add or subtract whatever is there, because since we're on the same side, I can just add them. So that means that's going to give me a negative 14x, and then positive 24, negative 4. That's going to be plus 20, and that's going to be less than 12. Now I'm going to move things around, so I'm going to subtract 20 here and subtract 20 here. And I'm going to get negative 14, x, and that's going to be less than, and this here is going to be negative 8. So then I divide by negative 14. Now this is where it's different. Anytime I multiply or divide by a negative number, I have to flip the inequality symbol. So that's the only thing you really got to remember when solving inequalities, is that if I multiply or divide by a negative, I have to flip the inequality. So now I'm going to get x is greater than, and then 8/14 is really 4/7. Since I have a negative over a negative, that's now positive. So x is greater than positive 4/7. And for this one, I have to reduce, and that's where this 4/7 came from. If I look at those two, 2 goes into both those numbers. So 2 goes into 8 4 times, 2 goes into 14 7 times. So there's our answer. Now we're not done yet, of course, because we have to write it in graph form and interval notation. So my graph form, I put the 4/7 down. And now I'm just going to read it from the variable side. X is greater than 4/7. So I'm going to use a parenthesis here. And it's greater than, so that means I'm being to the right. That's why I had my parenthesis curving to the right. and it's just going to keep going. So that's it right there. So then my interval notation is going to be parenthesis 4/7, comma, infinity. All right, so let's try this next one now. This next one is what we call a compound inequality because there's two inequality symbols in this one. And what we're going to do for this one is we're just going to treat this as like two separate equations. So the idea is I have this one, and I also have this one here. Okay, it's like I have two separate ones, but I'm going to do them together. Okay, so the first thing I would do is multiply both sides by 8. I actually should say all three sides by 8 because I have this one, that's going to be 8, that's going to be 8, and that's going to be 8. So this here is going to be negative 128, which is less than or equal to 4x minus 3 because those cancel. And that's less than 256 for this one here. And then I'm going to add 3 to all three sides. And then this is going to be 259. So now I just divide everything by 4. Now I don't have to flip it because it's not a negative 4 I'm dividing by. But if it was, then both of my inequality symbols would flip. Okay, so anyway, so this is going to give me negative 125 over 4 less than or equal to x less than 259 over 4. Okay, so now for my graph of this problem, I had to make this one a little longer because I have two numbers on there, and the numbers actually take up a lot of space. So this is going to be negative 125 over 4 and 259 over 4. And I'm including the negative 125 over 4. And I'm not including the 259 over 4. So I'm going to use a bracket for the negative 125 over 4. And I'm going to use a parenthesis for the 259 over 4. And then just draw a line between them. So there's my graph form. Now for my interval notation, really sets it up for me to make this an easy problem. Negative 125 over 4, comma, 259 over 4, parenthesis. So there's my two forms. One last problem. Okay, let's take a look at this one. Now this one's an interesting problem because I have to use a little bit more than just algebra. I should say algebra, manipulating symbols and stuff kind of problem here. All right, so I'm going to write a 0 here, less than. And this, since I have a negative exponent there, flips it into the bottom, so it's really this number, or this expression here, 2x minus 1 less than 1. So now a good thing is that I'm between 0 and 1, so that's a good thing. So really, this number down here has to be less than 1. No, bigger than 1. Because think about this, if this is bigger than 1, then 1 over that number is going to be less than 1. Hopefully that makes sense. I know that may sound a little weird here, but think about this. Let's say this number turned out to be 2. Then I would have 1/2. And I know 1/2 is less than 1. Okay, it kind of flips it. So if I had a 4 in there, so 1 over 4 then, okay, then that would be okay. So that bottom expression has to be greater than 1. So I'm just going to write that. 2x minus 1 has to be greater than 1. Because if it was 1, they'd be the same, and I'd have 1 over 1, which is not less than 1. So I need that to be greater than 1. Okay, so then I move the 1 over, so I get 2x is greater than 2. And I divide by 2, and then I get x is greater than 1. So x has to be greater than 1 in order for this to work. And 1 over 2x minus 1 will be less than 1. All right. So what does that tell us then? So then for the graph now, put the 1 on there. And x is greater than 1. No equal to, just greater than 1. So I'm going to use a parenthesis. And I'm going to go to infinity. So that's what it is. So then my interval notation will be parenthesis 1, comma, infinity with another parenthesis. So that's the last one here. Now, if I didn't have this greater than 0 here, that would raise even more issues for this problem, because I could have this be any negative number. So anything there could be less than 0, which raises another concern here and changes our problem a little bit more. But we don't have to worry about that here because our lower bound is 0. So it really helps out with this problem.